right. Once again, you are all welcome to today's session. This is the last class, the final class for the CCNA1 training that we have been doing. And we'll be looking at Module 17, Build a Small Network. And this particular module is basically a summary of all that we have been looking at. It actually has to do with some small topics or small components across the different topics. We're going to be looking at devices in a small network, and we will identify those devices, right, that are being used in a small network. We're also going to look at small network applications and protocols. So you see, after looking at the devices, we'll be looking at the applications. Then we'll be looking at how to scale, in other words, how small network serves as basics for a larger network, or rather how your network can expand and grow. We're going to look at how to verify connectivity. We're going to be looking at host and iOS commands and troubleshooting methodologies and troubleshooting scenarios. Okay, so let's go into it. The majority of businesses are small. Most of the businesses' network are also small. A small network design is usually very, very simple. Small networks typically have a single WAN connection provided by digital subscriber line or Ethernet connection. So a large network requires like an IT department to maintain and secure and troubleshoot, network devices to protect organizational data. Small networks are actually managed by a local IT technician or by a contracted professional. Okay. Device selection for a small network. Like large networks, small networks require planning and design to meet user requirements. So planning ensures that all requirements, cost factors, and deployment options are often given due consideration. One of the first design consideration is the type of intermediary devices to be used to support our network. And there are certain factors that must be considered when selecting these network devices. Number one is the cost. Okay. Then we'll look at the speed and type of ports or interfaces. Then we'll look at expandability, that is possibility of growth. So your choice of devices, that will come in. Then operating system features and services and so on and so forth. Those are the features that you bear in mind. Another area is IP addressing for a small network. So when implementing a network, you have to create an IP addressing scheme and use it. All hosts and devices within an internetwork must have a unique address. Devices that will factor into the IP addressing scheme actually include the end devices, and that's like the number and type of connections, whether you want to use wired or wireless, remote access, and things like that. Okay. You also look at the area of servers and peripheral devices, where you see if you want to connect printers, IP cameras, IP phones, and biometric devices and things like that. All right. You also have to look at intermediary devices, including switches, access points. So generally, when you are designing an IP address plan for your network, you have to put into consideration everything. So it is actually recommended that you plan, document and maintain an IP addressing scheme based on your device type. And the use of a planned IP addressing scheme make it easier to identify a type of device and to troubleshoot problems. Okay. Now, another area of interest is redundancy in a small network. Redundancy is where you want to ensure that there is no downtime. In case there's a problem, there is no downtime. So in order to maintain this high degree of reliability, you have to look at redundancy in your design. So redundancy can be accomplished by installing duplicate equipment, can also be accomplished by supplying duplicate network links for crucial or critical areas. So you could see that these are maybe your servers where your applications or your services are sitting. And you have like a set of switches, and basically all you just need is one switch. This is all you need. You just need one switch, you just need one router, and you are fine. But because of redundancy, you are having two here so that in case one fails, the other one can run into it. Okay? You have to look at also traffic management devices, because in this case, you are looking at the different type of data. You're looking at voice data, mail data or SMTP, instant messaging, FTP. You're looking at HTTP. You're looking at different traffic. All right. So the goal for network design is to enhance productivity of the employee and minimize network downtime. So the routers and switches in a small network should be configured to support real-time traffic such as voice, video, and data. Appropriate manner relative to other traffic. A good network design will implement quality of service. All right, so priority queuing has 4 queues. The high priority queues is always emptied first. All right, so that is it. How about the applications you need when you are setting up your network and protocols? Remember, we talked about the protocols or applications in the layer 7 of the OSI model. So after you must have set it up, your network will still need certain types of application and protocols in order to work. So the network is only as useful as the applications that are on it. And there are two forms of these softwares or programs. We have the network applications and we have the application layer services. The network applications are the applications that implement application layer protocols and are able to communicate directly to the lower layers of your protocol stack. And then application layer services actually are not network aware. They are programs that interface with the network and prepare the data basically for, for transfer. And then you have certain protocols that are very common that is required whenever you are setting up your small network. You have what we call the SSH. The SSH is a very important tool, especially for network administrators or system administrators, because they will actually need it to gain access to your servers, your intermediary devices, or even your core devices. So network administrators commonly actually require that. Okay. Another protocol is the HTTP, which is the Hypertext Transfer Protocol. And that is actually for web servers or browsing. All right. So it's another protocol that is needed. Another one is the SMTP. Okay. The SMTP is like for emails. Another one for emails is the POP3, which is the post office protocol, or the IMAP, instant messaging, instant mail access protocol. Okay. And they are all part of email services. Then you have the file transfer protocol and security file transfer protocol. They are used to download and upload files between a client and an FTP server. Okay. You have also the DHCP, which is the Dynamic Host Control Protocol, which is used by clients to acquire an IP configuration from a DHCP server. Then you have the domain name service, which is the DNS, that helps to resolve domain names to their corresponding IP addresses. So all these protocols, we have looked at them at the application layer, because those are the protocols that run at that layer. So when you are setting up a small network, you will also need them. So these network protocols comprise the fundamental tool set of a network professional, basically defining the processes and defining the types of messages, defining the syntax of the messages, defining the meaning of information fields, and how messages are sent and are expected to respond. So all these protocols, that is what they do. So you as a network administrator, you don't just configure and install protocols just like that. The protocol must have a need. You must have a need, and that's why you are going in for that particular protocol. Then you have voice and video applications. Okay. Business today are increasingly using IP telephony and streaming media to communicate with customers and business partners. So as well as enabling their employees to work remotely. So the network administrator must ensure the proper equipment is installed in the network and that the network services are configured to ensure priority delivery. So the factors that a small network administrator must consider when supporting real-time applications include the infrastructure, very key, the VoIP, which is voice over IP, then the IP telephony, and then the real-time application. Okay, so the administrator must consider them very, very well. So like the infrastructure, you look at the capacity, especially when you are dealing with real-time applications, whether the infrastructure can support it. Okay, and then when it comes to real-time applications, the network must support your quality of service mechanism in order to give you the best network traffic. How about when you want to scale to a larger network, or let's say scalability or expansion? All right. When you are designing your network, you have to design with a plan for expansion, so that by the time that expansion time comes, you don't need to start building the network from scratch again. So growth is a natural process for many businesses, small businesses, and their network must grow accordingly. Ideally, the network administrator has enough lead time to make intelligent decisions about growing the network in alignment with the growth of the company. So in order to scale a network, there are several elements that will be required. One of them is network documentation that has to do with the physical and logical topology. The physical topology is to see the current physical state of the network and how the devices connect one to another. And then you have plan to expand it. How do you intend to grow? Okay, and when the devices are connecting to one another. The logical topology have to do with the flow of traffic. How does your traffic flow from which place to another, from which device to another? Basically, your IP plan. Okay, then you also have your device inventory, which lists all your devices that use or comprises the network. Then you also have your budget. Itemize the IP budget, including fiscal year equipment, purchasing budget, and things like that. And then you now look at traffic analysis that deals with protocols, applications, services, and their respective traffic requirements that should be documented. So these elements are used to inform the decision making that accompanies the scaling of a small network. So when you are building a network, you have to have that in mind. Protocol analysis. It is important to understand the type of traffic that is crossing the network as well as the current traffic flow. There are several network management tools that can be used for this purpose. So to determine traffic flow pattern, it is important to do the following. One, to capture traffic during peak utilization times in order to get good representation of the different types of traffic, which means that as a network administrator, I now pick a day that there are a lot of traffic, then I will go and capture it. It will give me all the applications that people are likely to use, all the protocols that people are likely to use, and things like that. So if I'm going to form my policies, I'm going to form it based on that. Perform the capture on different network segments and devices, as some traffic will be local to a particular segment. Information gathered by the protocol analyzer is evaluated based on the source and destination of the traffic. So as well as the type of traffic being sent, this analysis can be used to make decisions on how to manage the traffic more efficiently. All right. Another area is employee network utilization. Many operating systems provide built-in tools to display such network utilization information. These tools can be used to capture a snapshot of information such as the operating system, the CPU utilization, RAM utilization, drive utilization, non-network applications, and network applications. So documenting snapshots for employees in a small network over a period of time is very useful to identify evolving protocol requirements and associated traffic flows. So how then do you verify connectivity? Verification of connectivity is just to test the reachability of end devices across the network. And one of the tools that we use is the ping tool or the ICMP protocol that is used to test reachability of end devices. And if you're able to use to test between PC A and PC B, and you are getting a very good reply or reachability, it means that everything on your network from here to here is fine. You don't have a problem. So, but if you are unable to reach it, then you know that your network have a problem. So the quickest and fastest way is by using ping, okay? Now, there are what they call extended ping when you are using it in routers or switches, especially when you are running the Cisco IOS. So it offers extended ping. And what does that mean? The extended ping is to say, okay, you are running a ping, but you are adding some more information. So it is usually done in the privileged executive mode, and you just type ping without the destination IP address. If you just type ping like this, you just press enter, it will ask you for the IP. You see here, it will ask you for the IP. Then if you enter the IP, then it will now ask you, it will tell you the default is that the ping is going to run 5 times. If you want to change that, you can change it. If you don't want to change that, you just press enter. It will tell you the size of the datagram. If you want to change it, you enter the size. If you don't want to change it, press enter. Then it will take you to the timeout as 2 seconds. If you want to change it, you enter the values. If you don't want to change it, fine, you leave it like that. Press enter. Then it will tell you extended commands. The default is no. If you say no, then it will not bring out the other details or parameters you need for the extended. But if you say Y, which is yes, then it's going to now ask you if you want to ping and specify the source address. All right. So if you enter the source address, then your ping is trying to say, okay, I am trying to run a ping, but I am targeting, I want the ping to be from a particular source address, not from the interface or from the device that I am entering, I am using. Okay, that's just the idea of the extended ping. Another way to check your network or verify your network is using the tracert or traceroute command. The tracert command is used when you're using it on a PC, while the traceroute command is used when you're using it on a router. So it can help you to locate problems from different areas. So if I run tracert from this system to test my reachability to be, it's going to bring out details on this router, on this, before it gets here. So if there is a problem here, I'm going to know where the problem is. So that can be done for tracert and ping in order to verify connectivity, right? These are all part of the ping. Now, network baseline. One of the most effective tools for monitoring and troubleshooting network performance is to establish a network baseline. Okay? One method for starting a baseline is to copy and paste the result from an executed ping trace or other relevant command into a text file. These text files can be time-stamped with the dates and saved into an archive for later retrieval and comparison. Among items to consider are error messages and the response time from the host to host, and then also corporate networks should have extensive baselines, more extensive than we can describe in this course, right? So that is the most important that you have there. Host and iOS commands, okay? Now, IP configuration on a Windows host. Basically, you need to now know how to check your details. If you use the ipconfig command, it will bring out your IP address, subnet mask, and default gateway. If you use ipconfig /all, you're going to get some other details as well, including your default gateway, your DNS, your DHCP, your lease time, and so on and so forth. All right. If you want to release these IPs because they are leased, you just use ipconfig /release, and then you are good. If you want to renew it and get a fresh one, just do ipconfig /renew. If you do that, then you are good. Okay. But if you're using it on a Linux system, you don't use ipconfig. You use the command ifconfig. Once you use ifconfig in the Linux command, it's going to give you the details, the INET address, which is the IP address, and then it will give you the broadcast address. It will give you the network mask as well. Okay, so that is how to use it on Linux. So the Linux IP address command is used to display addresses and their properties. Okay, so in the GUI on the Mac, all you just need to do is open the network preferences. When you do that, you click advance in order to get the IP address information. So the ifconfig command can also be used to verify the interface IP configuration at the command line. So other useful Mac OS commands to verify the host IP include the network setup dash list install network services, and then the network setup dash space dash get info. Okay. How about the ARP, Address Resolution Protocol command? The ARP command is executed from the Windows, Linux, or Mac command prompt. The command lists all devices currently in the ARP cache of the host. The ARP -A command displays the known IP address and the MAC address binding. The ARP cache also only displays information from devices that have been recently accessed. So to ensure that the ARP cache is populated, ping a device so that it will have an entry in the ARP table. So the cache can be cleared by using the netsh interface IP delete, right? So that is that one. So there are some commands that you can visit. If you take note of these commands, it will help you in your troubleshooting skills. For instance, show running-config helps you to verify the current configuration in settings. Show interfaces verifies the interface status and display any error message. Show IP interface verifies the layer 3 information of an IP interface. Show ARP verifies the list of known ports on a local Ethernet LAN. And then show IP route. Verifies the layer 3 routing information. All right. Show protocols, verifies which protocols are operation, and finally show version, verifies the memory interface and licenses of the device. So all these commands are very, very important, especially when it comes to troubleshooting. Other commands include show CDP neighbor. This one actually gives you the details of your connected device, the neighbor devices to your router or your switch. So the CDP provides information about your neighbors, like device identifiers, address lists, port identifiers, capabilities, and platforms, and things like that. Okay. Then another interesting command is the show IP interface brief. It's a very, very frequently used command, especially to show the status of your interface, whether it is up or it is down, and to know the protocol, whether it's up or down. All right. So that one is there. Finally, let's look at troubleshooting methodologies. Troubleshooting is basically a step-by-step way of identifying a problem and solving it. Okay, so in order to identify the problem, you have to follow certain small process and things like that. So there are tools that you can be used for this particular step. You know, conversation with a user is often very helpful by asking him what happened that your system is down, what happened that you're not able to access this, and then he gives you an idea. Then you can now establish a theory of probable cause. Okay, because you will use some tools and do like that. So that theory is to say, okay, I think the problem may be that your interface is down or your network cable is bad or whatever it is. Now, if you are able to bring out this theory, then you go to step 3, which is to test the theory and determine the cause. So based on the information you have gathered, you run a small test to verify that particular theory. If you verify that, then you establish a plan of action and implement a solution. And this is usually done after you have determined the exact cause of the problem and establish a plan of action to resolve the problem and implement the solution. After that, you go to step 5, which is to verify solution and implement preventive measure. Very, very important. Then finally, go to step 6, document your findings, your actions, and your outcome. After that, you ask whether the problem has been resolved. If it has been resolved, fine. If it has not, then you escalate, right? Debugging also is another way you use in troubleshooting because it brings out the details of your traffic analysis or your troubleshooting process. So if you use the debug command, it brings out the messages in a particular way. It displays like log messages on your terminal. All right. So, and usually you use it in your privilege mode. So you can say terminal monitor, you use it on your privilege mode. Okay. And then that is it. This is an example of a troubleshooting scenario where you have a duplex operation and a mismatch. And it's similar to a question that someone asked, I think in the last class or the class before the last. So interconnecting Ethernet interfaces must operate in the same duplex mode, which is full duplex or half duplex. So the Ethernet auto-negotiation feature facilitates configuration, minimizes problems, and maximizes link performance between two interconnecting Ethernet links. So the connected device first announced their supported capabilities and then chooses the highest performance mode, all right, supported for both ends. So if one of the two connected devices is operating in full duplex and the other is operating in half duplex, a duplex mismatch occurs. So while data communication will occur through a link with a duplex mismatch, the link performance may be very, very poor. So a duplex mismatch are typically caused by a misconfigured interface, or in a rare instance by a failed auto negotiation. Duplex mismatches may be difficult to troubleshoot as the communication between the devices still occurs. So if you are using a Cisco device, sometimes you see like the port blinking amber. All right, you see it blinking amber, meaning to tell you that there is an issue over there. Default gateway issues. The default gateways for an end device is the closest networking device belonging to the same network as the end device that can forward traffic to other networks. So if a device has an incorrect or non-existent default gateway address, it will not be able to communicate with the device in the remote network. So similar to the IP version 4 addressing issues, default gateway problems can relate to misconfigurations, right? So to verify the default gateway on a Windows-based computers, you can use the ipconfig command on a router. Use the same show IP route command to the list of the routing table and verify that the gateway shown as the default route has been set. So the route is used when the destination address of the packet does not match any other routes in its routing table, right? So how about DNS? It is common for users to mistakenly relate the operations of an internet link to the availability of DNS. So DNS server addresses can be manually or automatically assigned via DHCP. Although it is common for companies and organizations to manage their own DNS servers, any reachable DNS server can be used to resolve names. So Cisco offers OpenDNS, which provides secure DNS services by filtering phishing and some malware sites. So the OpenDNS you can use is 208.67.222.222 or 208.67.220.220. So advanced features such as web content filtering and security are available to families and businesses. So use the ipconfig/all to verify your DNS. Ladies and gentlemen, congratulations. We have finally come to the end of this training. Unless maybe there are questions, we're going to take questions if there are any, and then we will call it a day. All right. So any question?